Every year I try to do at least one programming-oriented and one non-programming-oriented. This is my programming-oriented, so there won't be any code in it.
Who's got the timer going?
The idea of an algorithm description to me is minimum number of facts so that everything just logically falls out and maybe you can even pick up something useful out of it. What's the fair allocation problem? Given a target amount divided proportionally across a set of weights in the statistical sense. So splitting up a tip, allocating overhead costs from an invoice, and so on. The issue here is not whether to use a int, long, big decimal, an exact type, versus an approximate type like float or double. This is a design problem that remains after you make that decision. So a typical approach for this sort of thing that you see all over the place is sum the weights, then for each weight in the set of weights, compute the ratio of that one to the total, multiply the ratio of the target. The rounded product is this weight's share. So, okay, yeah, the end. We've all seen that one before. Worked example, target of 8, weights 2 and 1 and 1. So the sum of the weights is 4. The ratios are 2/4, 1/4, 1/4. Multiply it out, you get a product which you can reduce, 4, 2, and 2. That's the share. The per product, or per weight share values, total to the sum, to the original target. So what's the big deal? Well, it doesn't always work that nicely. Target of 8 and 3 equal weights gives me 1/3, which when we multiply out gives 8/3, and when you round those, every share is 3. The sum of the shares doesn't equal the target. And it gets worse. 7 equal weights produces, for 11, an allocation of a total of 14. Something is wrong here. How do we fix it? And you see all sorts of suggestions made for how to fix it. Do you adjust the last one to make it balanced? Do you redistribute the leftovers somehow? Do you do some sort of brute force, do the biggest one first? All manner of complexity, like tweaking the plain old bubble sort, right? These are wrong answers because they're asking the wrong question. The root cause is premature concern with little details. We programmers love to skip past the big picture and focus on some little juicy technical issue, and we end up creating things that are penny-wise but pound-foolish. What's the solution? We want to enforce the correct total. Duh. How do we do that? Well, the proof of correctness guys have been telling us for years that a good heuristic is transform a post condition into an invariant. That is, thus far. If you want something true at the end, make sure it's partially true all the way through. And you enforce that partial correctness at every step, because quality is about what you do all along the way, not what you conclude when you get through. So, here's a worked example. Again, 8 with 3 equal weights. The weight subtotal, 1, 2, and 3. The subtotal ratios, 1/3, 2/3, 3/3. The subtotal products with the target. And when we reduce those, we now have some numbers that we can round to get the rounded subtotal products. These are the subtotals that we have to hit. So we simply share for each item the amount it takes to hit the subtotal. And the same thing happens with our bigger, uglier example. Notice that the odd bits are getting distributed across along the way rather than any second patch-up kind of a pass. What does fair mean? It means that the shares total the original target. It means that each per weight share is guaranteed to be within 1 unit of its ideal ratio. How do we know that? Well, the ideal share is the difference between ideal subtotals. When you round the subtotals, you're going to get a value that's within 0.5 either way. Therefore, the differences between those are going to be within 1 either way. Guaranteed. The moral of the story, think globally, code locally.